There's a $2 powder sitting on hardware store shelves right now, and it can make blackened silver shine like polished mirrors in minutes. Not a weaker version, not good enough, the full effect. And variations of this exact method were used by Roman metalworkers, Persian silversmiths, and medieval Japanese craftsmen long before modern jewelry cleaners existed. Most people think tarnish means silver is damaged, that the dark gray coating spreading across old jewelry, silverware, coins, and antique cups is some kind of permanent decay. But tarnish is not rust. Silver isn't crumbling apart the way iron does. It's reacting. That black layer is usually silver sulfide, a chemical film formed when sulfur compounds in the air bond to the silver surface. Candle smoke, eggs, pollution, rubber, wool, industrial air. Even human skin oils can slowly trigger it. And ancient metalworkers figured out something astonishing thousands of years ago. You can reverse the reaction, not scrub it away, not polish the metal down thinner every year, actually reverse the chemistry itself. In ancient Rome around the 1st century AD, wealthy families used silver dining sets as status symbols. Archaeological excavations in Pompeii uncovered heavily tarnished serving trays and ceremonial silver cups buried beneath volcanic ash from Mount Vesuvius in 79 AD. But Roman writings from Pliny the Elder describe methods of restoring silver using alkaline ash mixtures and heated water treatments. They didn't know the modern chemical terms, but they knew the effect. In Persia, during the Sasanian Empire around the 500s AD, silver bowls and engraved plates were prized across royal courts from Ctesiphon to Central Asia. Craftsmen discovered that certain mineral-rich salts and alkaline compounds could strip dark sulfur films from silver surfaces while leaving the metal itself largely untouched. Many workshops heated these mixtures in bronze vessels until the liquid turned cloudy white, then immersed decorative silver pieces for short periods before rinsing them in cool water. The transformation looked almost supernatural, blackened silver emerging bright again beneath thin wisps of steam. Half chemistry, half magic trick. And the same pattern appeared again in medieval Japan. Sword fittings, tea ceremony utensils, and ceremonial silver ornaments often darkened from humidity and sulfur exposure. Historical restoration records from Kyoto workshops describe craftsmen using mineral powders, dissolved into hot water alongside reactive metals to restore brightness without excessive abrasion. Different continents, different languages, same discovery, that matters. Because when civilizations separated by oceans independently discovered nearly identical methods, you're no longer dealing with folklore. You're looking at convergent engineering knowledge. And then something fascinating happened in the early industrial era. By the 1800s, European chemists began studying silver tarnish scientifically. Michael Faraday's work on electrochemistry helped explain why certain metals transfer electrons during chemical reactions. By the early 20th century, laboratory experiments confirmed what ancient craftsmen had accidentally discovered through observation. Silver tarnish could be chemically converted back into silver under the right conditions. No aggressive polishing required. That principle is still used today in museums restoring antique silver artifacts worth millions of dollars. The science is surprisingly simple. Imagine tarnish like a layer of soot stuck to silver. Most commercial cleaners work like sandpaper. They grind the layer off physically. That works, but every polishing session removes microscopic amounts of actual silver too. Ancient restoration methods work differently. Instead of scraping the damage away, they convince the sulfur to leave the silver entirely and attach itself somewhere else. The stain abandons the metal. That's the trick. And once you understand that, modern silver cleaning products suddenly start looking very strange. Because many expensive, advanced silver cleaners sold today still rely on versions of the exact same chemistry discovered centuries ago. Sometimes the active ingredient costs pennies, but the packaging, branding, and specialty labels inflate prices by 800 to 1,200%. A tiny bottle, a luxury logo, a dramatic markup. Meanwhile, the raw material itself often costs less than coffee. If these kinds of forgotten stories matter to you, subscribe and ring the bell, because this channel exists for one reason: dragging buried knowledge back into daylight before it disappears behind branding and retail markups forever. Now here's where things become uncomfortable. The global jewelry cleaning and silver care market generates billions every year. Add luxury restoration products, polishing cloths, silver dips, ultrasonic machines, and commercial metal care systems. And suddenly, there's enormous financial incentive to make silver maintenance feel complicated. But a permanent dependence model has a problem. It cannot tolerate $2 solutions. And eventually, the industry noticed. The silver care industry quietly depends on repetition, not restoration. Repetition. Think about how most silver cleaning products are marketed. Tiny bottles, tiny wipes, tiny polishing pads. Use regularly, repeat monthly. Special formula. Professional strength. But many of these products share an uncomfortable secret. The underlying chemistry is often incredibly old. In some cases, the active cleaning principle traces back thousands of years. The global jewelry cleaning market alone is estimated in the multi-billion-dollar range when combined with luxury restoration services, specialty polishing products, silver dips, ultrasonic machines, anti-tarnish coatings, and maintenance accessories. Entire retail categories exist around the assumption that silver maintenance requires specialized branded solutions, and some of those solutions cost $30 to $50 per kit. Now, compare that with sodium bicarbonate, ordinary baking soda, $2, sometimes less. Think about that for a moment. A cheap alkaline powder sitting beside flour and pancake mix can trigger the same fundamental chemical process used in museum restoration labs and professional silver recovery systems. That's not conspiracy theory territory, that's chemistry. Here's what's really happening. Silver tarnish forms when sulfur atoms bond with silver atoms, creating silver sulfide. Picture it like microscopic black armor coating the surface. Traditional abrasive cleaners physically scrape that layer away, which also removes tiny amounts of silver itself over time. That's why antique silverware gradually loses detail after decades of aggressive polishing. Edges soften, engravings fade, patterns flatten. But electrochemical cleaning works differently. Instead of grinding away tarnish, it transfers sulfur atoms off the silver and onto another reactive metal, usually aluminum. The disease becomes the cure. The tarnish itself participates in its own removal. When hot water, aluminum, baking soda, and silver interact together, electrons begin moving between metals. Sulfur abandons the silver surface and bonds preferentially elsewhere. The black coating disappears because the chemical structure itself changes. Not hidden, not mystical, just electron transfer. Researchers studying electrochemical silver restoration documented versions of this process throughout the 20th century. Conservation departments at institutions like the Smithsonian and the British Museum have repeatedly warned against excessive abrasive polishing because preserving original silver surfaces matters enormously for historical artifacts. And yet most consumer marketing still pushes friction-heavy cleaning methods because they create repeat purchasing cycles. The more aggressively people polish silver, the faster fine details disappear. The more often tarnish returns, the more products get sold. That cycle is profitable, especially when products are marketed emotionally instead of chemically. Luxury silver care brands often use words like advanced formula, professional shine, or deep restoration complex. But if you examine ingredient labels closely, many rely heavily on simple alkaline compounds, surfactants, or mild abrasives costing pennies per ounce before packaging. Some silver polishing cloths retail for $20 despite containing chemical treatments based on extremely inexpensive compounds. Branding transforms common chemistry into premium ritual, and this pattern exists everywhere once you start noticing it. Laundry detergents, rust removers, drain cleaners, metal restoration products, simple compounds repackaged into recurring dependency systems. Now, to be fair, not every commercial product is useless. Some include protective anti-tarnish agents or specialty coatings helpful for museums and collectors. But for ordinary household silver restoration, the gap between actual chemistry and retail pricing becomes difficult to ignore, especially when the core mechanism has been understood for generations. And here's another strange detail. During World War II, military engineers restoring silver electrical contacts and sensitive components often preferred chemical cleaning methods, specifically because abrasive polishing damaged precision surfaces. Similar principles appeared in industrial maintenance manuals throughout the mid-20th century. The science was settled decades ago, but simplicity rarely wins marketing wars. Complexity does. If you've watched this far, you already understand more about silver restoration chemistry than most people buying expensive polishing kits at department stores. Subscribe and share this, because the more people understand the underlying science, the harder it becomes to sell ordinary chemistry disguised as luxury mystery. Now let's make this practical. Because the most satisfying part of this entire story is how absurdly simple the actual process is. You probably already own half the materials, and the remaining half costs less than lunch. Here is exactly what to do, and it's almost insultingly simple. You need 4 basic things: baking soda, aluminum foil, hot water, and a container large enough to hold the silver item. That's it. First, buy ordinary baking soda. Any grocery store works. Walmart, Aldi, Dollar Tree, local markets, doesn't matter. A standard 1-pound box usually costs between $1 and $3 and lasts through dozens of cleanings. Next, get ordinary aluminum foil. No specialty type required. Now line the inside of a bowl, tray, pot, or glass container with the foil shiny side upward. The silver item must physically touch the aluminum during the process. That contact matters because the electron transfer happens between metals. Place the tarnished silver onto the foil. You'll notice black, gray, or brown discoloration across the surface. Sometimes it looks oily, sometimes chalky. Heavy tarnish often appears almost charcoal-colored under bright light. Now sprinkle baking soda generously over the silver. About 1 tablespoon per cup of water works well for most items. You don't need exact laboratory precision. The mixture should dissolve into cloudy hot water resembling thin milk. Then slowly pour very hot water over everything. Not boiling violently, just extremely hot. Within seconds, something remarkable happens. You may smell faint sulfur, rotten eggs, old mineral water. That smell is evidence the sulfur compounds are moving during the reaction. Tiny bubbles may form along darkened surfaces. Tarnish begins fading unevenly at first, then rapidly disappears in patches. Silver hidden beneath years of black coating suddenly flashes bright again. Not polished bright, original bright. Let the item sit for about 30 seconds to 3 minutes, depending on severity. Extremely tarnished pieces may need a second round. Gently rotate the item if necessary, so all surfaces contact the aluminum solution. Then remove the silver carefully and rinse with cool, clean water. At this stage, most pieces already look shockingly restored. Dry completely using soft cloth or microfiber towels. If slight residue remains in recessed details, use a soft toothbrush gently. No heavy scrubbing required. That's the beauty of the process. The chemistry does most of the work. Now here's where people make mistakes. Never use this method aggressively on silver-plated antiques with damaged plating, glued gemstones, pearls, or delicate oxidized decorative finishes intended to remain dark, and avoid combining different unknown metals together during cleaning. But for ordinary sterling silver jewelry, utensils, trays, cups, chains, coins, and household silverware, the results can feel almost ridiculous for the cost, and you can expand the system further. Some restorers add small amounts of salt to accelerate conductivity slightly. Others use shallow foil-lined sinks for large serving trays. Campers restoring silver utensils outdoors sometimes heat water over propane stoves and perform the reaction inside metal pans. The chemistry scales beautifully. A collector in rural Pennsylvania tested this exact method on heavily tarnished silver flatware inherited from his grandmother in 2022. The set had remained untouched inside a damp basement cabinet for nearly 20 years. Before cleaning, the pieces appeared almost gunmetal gray under kitchen lighting. After 2 treatment cycles, lasting less than 10 minutes total, engraved floral patterns hidden beneath tarnish became visible again. That's because the silver underneath was never destroyed. It was buried. And that idea matters far beyond silverware. Roman craftsmen knew this. Persian metalworkers knew this. Japanese restorers knew this. Museum conservators know this. Your grandparents probably knew parts of it too. But somewhere along the way, simple chemistry became premium branding. A multi-billion-dollar maintenance industry depends on people believing restoration requires specialized products, constant polishing, and expensive formulas hidden behind luxury packaging. But sulfur still follows chemistry. Electrons still move between metals, and baking soda still costs almost nothing. This knowledge never disappeared. It was simply marketed out of visibility. Because chemistry doesn't care about brand strategy, and nature has never charged a licensing fee. Every share cracks the wall they spent billions building. Every subscription keeps this channel digging deeper into the vaults they thought were sealed forever. The next vault opens soon, and what's inside may completely change the way you think about rust itself.